In this video, we'll talk about storing long numbers. These are basically integers, but they can store numbers that are far bigger than regular integers. Now, this is definitely an advanced topic. Integer variables can hold huge numbers. You can program for years and years and never need to store a number bigger than what an int can hold. But if you ever do find yourself needing to store a truly stupendously large number, then you can use a long. Here's an example where a long could be useful. Suppose that you're writing a sketch for visualization. Your topic has to do with hair, specifically how many hairs there are on all the heads of all the people alive today in the United States. Well, that's a crazy thing to think about, but you can imagine someone wanting to know it. So you go to your favorite search engine and you look up how many hairs are on the average human head. If you multiply this by the number of people alive in the US today, you'll have an estimate for the total number of hairs. So let's do that. I'll use two integers. The first, people in US, has the current population. The second, hairs on head, is the average number of hairs on a human head. I'll assign them the values that I found from an online search. We can multiply these together and save the result in a new integer, which I'll call head hairs in US. Well, that's the whole program. Let's print everything out. For comparison, I'll also print out the right answer. I computed this using a special math program designed for huge calculations. And you can guess why I need to print this out. But let's go ahead and run it and see what happens. Here's the result, and the value we calculated isn't even close to the right answer. In fact, it's not even a positive number. So this is just a crazy nonsense result. What went wrong? Well, let's take a look at what we printed out. Hairs on head is correct, and people in US is correct, so I don't have an accidental typo in there. But somehow, when I multiplied them together, I got a crazy result. Well, the problem is this. Integers can hold any number from -2 billion to +2 billion, and that's a huge range. But this number is way, way bigger than that. It's like trying to put a bulldozer into a shoebox. The object is simply way too big to fit in the container. Now, processing doesn't check to make sure that the number can fit into the variable it's being assigned to. It would be nice if it did. It would be nice if it said, hey, I'm sorry, you're trying to put a number into an int and it's too big. It could do that, but it doesn't. It could just stick in the biggest number it can fit, but it doesn't do that either. It just silently tries its best. But in this case, it totally messed up and we got back junk. The solution, of course, is to use a long rather than an integer, because longs can hold much bigger values. Here's the very same program, but I changed all the ints to longs. When we run it, we get the right answer. Great. So that's the beauty of longs. Let's now compare the range of numbers that you can save in an integer and in a long. Ints themselves are huge. An integer variable can hold a number from -2.1 billion to +2.1 billion. To get a feeling for this huge number, 2.1 billion is 23 times the distance from the Earth to the Sun in miles. It would take a beam of light over 3 hours to cross this enormous distance. So how much bigger is a long? A long can store a number from 0 to positive or negative 9.1 quintillion. That's 4 billion times the range of the ints. This number, a quintillion, it is so big it's hard to imagine. But here's one attempt. It's the distance in miles that gets us halfway to the Andromeda galaxy. It takes a beam of light 1.5 million years to cross this distance. and you can store that number in a long. It's hard to imagine you'll ever need to store a number bigger than what a long can hold. Since longs are so much bigger than ints, why not use longs all the time? There are a few answers, but two are the most important. First, working with longs is slower. Every calculation that you do that involves a long will take much longer than if you used an int. These kinds of operations can add up very fast, and suddenly your snappy little interactive sketch becomes a slow and sluggish beast. The other problem is that none of processing's built-in operations will work with longs. So if you want to use a long to control anything in processing, from drawing a rectangle to choosing a color, you have to turn it into an integer first. And this is usually a terrible idea, because if your long is bigger than what an integer can hold, then you really can't turn your long into an integer. You'll just get junk. After all, if your number was small enough to fit into an int, then you might as well have used an int in the first place, giving you a faster and more flexible program. So these are real problems. But in those rare situations where you need to use a long, here's how to put a value into one of them and how to turn it into an integer. Here's an assignment statement where I'm putting some huge number into a long variable named longvar. When I run this program, I get an error. Why is that? The problem is that processing looks at the right-hand side of the assignment statement first. It sees a big number with no decimal point, and by default it says, that must be an integer. So it just sticks that value into a temporary little integer. As we've seen, storing a too big number in an integer gives us back junk. Here I'm illustrating the problem by lopping off the ends of the number we're storing, leaving just the middle digits. But as we've seen, the reality is that the number that goes into the int is essentially random. It might even be negative. Now that processing is finished with the right-hand side of the equal sign, it turns its attention to the left side. So it says, okay, I've got to take the value I have on the right-hand side and put it into longvar. But remember, the value on the right-hand side is now an int. So processing is taking a number on the right-hand side, saving it as an integer, which turns it into junk, and then assigns that integer to longvar. Somehow we have to tell processing that the number on the right should be interpreted as a long from the very start. To do that, we put the capital letter L at the end of the number. Now this only works with actual numbers, not variables. If you have a bunch of digits defining a number, putting a capital L at the end of the digits tells processing this number is a long. If we write the line this way, the assignment happens properly. Now suppose that you want to turn your long into an integer. Well, we have to explicitly tell processing to do this. The technique of changing a variable from one type to another is called casting, meaning that we're changing the type of the variable. We also say that we're going to cast the long as an int. There are two ways to write this cast. In the first, you call the function int with the long variable as the argument. Now the function name int, int, is exactly the same word as the name of the data type, and that's on purpose. Processing won't confuse these because this int is followed by a pair of parentheses, and inside is a number. Processing will take the number inside and turn it into an integer. If the argument to int is small enough to fit into an integer properly, then this will simply do the right thing and give you back the right int. But if the argument is too big for an int, this will return the largest value that the int can hold, or about positive or negative 2.1 billion. There's a second way to write a cast, but it doesn't work nearly as well, and I suggest that you avoid it. I'll show it to you because you might see it in other people's code. In this other form, you write the word int in parentheses just before the long variable you want to convert. When you write it this way, if the long value is too big to fit, then this is going to put junk into your integer. So I suggest that you avoid this form of casting, even though you might see it in other people's code. The better way to convert an int when you have to do it is to pass the long as an argument to the function int. Generally speaking, you'll probably never need to use a single long, ever. But if you do need to occasionally store an astronomically large number, now you know how.